For page 57, title it Graphs of Rational Functions. And the first thing you're going to do is you're going to pause the video and you're going to fill in these two tables here. Please don't just write down what I have. Use your calculator to actually go and calculate those numbers, or your brain. You don't really need a calculator. Okay? So now that these values have been plugged in, we have here graphed 1 over x. We've plugged in some very specific numbers that are very, very, very close to 1, as you can see. And then these numbers get plotted over here. So for example, 10, comma, is that 10? Oh, 1, I'm sorry, 1. So these are counted by 0.1. Sorry, that's not 10, that's 1. So if I plug in 1, for example, I get out 1. If I plug in 0.9, I get out 1.1 repeating. If I plug in 0.8, you get out 1.25. If you plug in 0.7, you get 2, and so forth. What you'll notice as we're plotting these, the values are starting to get higher and higher. And then when you get here, for example, to 0.1, you get 10. But then when you go to 0.01, which I can't even graph now because it jumps up to 100 all of a sudden. So at first, the change 1, 0.9, 0.8, and so forth, the change in your y values are very negligible, very, very small, from 1 to 1.1, 1.1 to 1.25, 1.25 to 2, and so forth. But the closer we get to 0, the number 0, as x is going closer and closer, 0.01, 0.001, and so forth, you'll notice these values are actually jumping up very quickly. So now it goes from 5 to 10, only just by doing x equals 0.2 and x equals 0.1. And then it jumps from 10 to 100 just from doing 0.1 to 0.01. If you would plug in 0.001 here, 1/1000th, this would actually be the number y equals 1,000. So you'll notice that these y values are actually jumping very, very quickly as you get closer and closer to 0. So the way that you write that mathematically is there is that arrow notation we'll see again. This says as x approaches 0, you'll notice that there's a little superscriptive plus here. That means from the right-hand side. So all of these values that I'm plotting right now, all of them are on the right-hand side of 0. And I'm getting closer and closer to the number x equals 0, which is the y-axis. So this is what this is saying. As x approaches 0 from the right, we're looking to see what y is doing. This black line shows you that y is jumping up all of a sudden to infinity. And these y values here show that as well. So as these x values get closer and closer to 0 from the right, you'll notice these y values are getting closer and closer to infinity. They're jumping up very, very quickly. And so that's how we write that. X approaches 0 from the right, y approaches infinity. Well, what this means is that we have a vertical asymptote at x equals 0. So if you look at your first note down here, it says the line x equals a is a vertical asymptote if f of x increases or decreases without bound. That means it goes to infinity or negative infinity as x approaches a. The way we write that is that f of x approaches infinity, which is the arrow notation here, as x approaches a. This can be either from the left or the right-hand side. If you want it to be from the right side, you put a little superscriptive plus. If you want it to be from the left side, you put a little superscriptive minus. And so that's how you know that there's a vertical asymptote. You can see it both in the graph here at 1 over x. There really is a vertical asymptote at x equals 0. But you can also see it here in the table where those values start to jump up significantly fast. Now, we said that this can be true if f of x approaches negative infinity as well. It says increases or decreases. If you look here, as x approaches 0 from the left now, as x approaches 0 from the left, we have that f of x is actually approaching negative infinity. So either from the left-hand side, it needs to approach negative infinity or infinity, and from the right-hand side, it needs to approach infinity or negative infinity, as you are approaching a vertical line, x equals some number. And if that happens, then you have a vertical asymptote. And this is how we signify that. F of x approaches infinity as x approaches a. Now, for the second table, I had you plug in x values that are actually getting very large. Instead of getting closer and closer to 0 like the first table, these values are getting very, very large. So 10, 20, 50, 100, we could put 1,000 in here and so forth. So when you first do this, if you plug in, for example, 10, it's 1/10. So I can't even graph that because I don't have enough room, but it would be 10, 0.10. 20 would be 0.05 to graph. 50, 0.02, and then 100 would be 0.01. If you continue this table, 1,000 would be 0.001, 10,000 would be 0.0001, and so forth. So you'll notice that those y values are getting closer and closer to the horizontal axis, which is y equals 0. And so here, the way we denote that is as x approaches infinity. What that means, these x values over here are getting very, very large. It says that y is approaching 0. So as x gets very large, these y values are getting closer and closer to the x-axis, which means y is approaching 0. We actually call this a horizontal asymptote. There was one at y equals 0. And looking at the graph of 1 over x, you can see that there really is one at y equals 0. And the way we denote that, as I said, is x arrow infinity, which means as x approaches infinity. F of x arrow 0, which means f of x approaches 0. And that is the actual definition of a horizontal asymptote. So if you come down here to your second note, it says the line y equals b, that's a horizontal line, is a horizontal asymptote if f of x approaches b, which whatever that y value is that you're approaching horizontally, as x increases or decreases without bound. So you'll notice we're switching who's increasing or decreasing without bound. In the vertical asymptote, y was increasing or decreasing without bound. But in horizontal asymptote, x is increasing or decreasing without bound. And so f of x, arrow b, means f of x approaches b as x approaches infinity. And you could do this for x approaching negative infinity as well. Whether it's infinity or negative infinity doesn't matter. You'll have a horizontal line that is going to be your horizontal asymptote at y equals b. And that's it for this page.